Welcome back to the course overview of Huawei SDN all-service solution. Now we will have a closer look at the SDN-based IP core used as for data center interconnection in the Huawei SDN solution. The SDN-based IP core is supporting a bunch of methods to provide path optimization. So this solution will help to improve network utilization and finally again will save money for the carriers. These implemented methods on the SDI controllers are RR+ for IGV, which is International Gateway, PCE+ with Smart Traffic Engineering, IP plus optical integration on the controller, and RR+ for DCI. We will immediately talk about these methods in more detail. But before, let's have a more general view. This slide shows a comparison between traditional core network architecture and SDN-based core network architecture. Traditional core network architecture is distributed and has a clear focus on network connectivity. This means that O&M people need to understand the principles of interior and exterior gateway routing protocols. This results in a relatively low network utilization due to the lack of a global or an end-to-end view. It is more based on a local perspective. If you think about configuration, for traditional networks, manual configuration needs to be done for all network elements. This also means a low O&M efficiency. It takes a lot of time to configure all the network elements in a huge network. If we compare that with the SDN-based network approach, then we can see that SDN network architecture is centralized, and SDN provides a multidimensional routing algorithm based on a global topology, supporting service level agreements, line costs, etc. So this results in an improved network utilization due to this overall network view. If we think about configuration, SDN-based networks are supporting an automatic configuration, and this strongly simplifies O&M and makes that much more efficient, and this finally is saving costs. Now we will go into more details about the Huawei SDN-based IP core solution. Basically, Routing Reflect Plus, RR+ technology can be introduced to realize traffic steering in a traditional IP network. In an IP network, setting and adjusting the metric of the IGP routing protocol is the most practical method to control traffic and optimize network performance. Typically, both the Interior Gateway Protocol IGP and the Border Gateway Protocol BGP are deployed to forward traffic from one domain to another. The IGP is responsible for the internal routing, the BGP is responsible for the interdomain routing. The following problem can arise when setting and adjusting IGP metrics. Routers considers only the destination, not the source of a route, and therefore cannot steer traffic per user flow and is based on its own IGP metric and local information. Now with RR+, using enhanced routing reflection, this is introduced to steer traffic in IP networks. It uses a centralized computation for routes and uses BGP to control the router's routing information base. So RR+ enhances the route reflection with computation based on IGP and eBGP metric on source and destination address and considering both the links and the service's bandwidth requirements. So to support RR+, the SDN controller consists of three modules, as you can see on this slide. Collect Network and User Service Real-Time SLA module, which uses NetStream BGP accounting to get real-time traffic information and traffic matrix. The Forecast Planning based on Service Policy module defines traffic policy and constraints coming from OSS, BSS. And the RR+ module, which calculates path based on RT traffic and constraints use BGP to build control paths with network devices and adjust BGP path attributes and routing policy based on newly calculated paths. In that way, it can be used to steer IP traffic. RR Plus can be used for automatic optimization of international gateways ingress traffic, as you can see here. To get to this point, the international gateway needs to send traffic statistics to the central SDN controller. The controller uses its collects network and user service real-time SLA module, uses its forecast planning based on service policy module, and propagates that to its RR Plus module. This module now selects its preferred network entry point and informs all relevant devices, provider routers, provider edge devices, and route reflectors about the preferred entry point and adjusts the incoming traffic according to that policy. The decisions about traffic adjustment can be based on many different parameters like lowest cost or interface based, etc. For path computation, we may have multiple constraints like excluding of unsatisfied paths according to bandwidth or high link utilization, etc. Or we may have packet delay requirements and so on. We also may use RR Plus as for the selection of our preferred exit gateway router to provide service level agreement guarantees also to the virtual customer edge VCE. Also for this scenario, we may take into account different parameters like link bandwidth or link utilization as shown in this slide. For the interconnection of core routers, we are using fiber optics. To provide redundancy in case of a network failure without the integration of IP routing and optical transmission in the shown scenario, no more than 50% of the bandwidth can be used if you want to provide redundancy. Because the traffic of the fiber 2 needs to be transmitted within fiber 1, within the same wavelength lambda 1. Now, the proven Huawei solution provides integration of IP routing and optical transmission based on SDN. This solution is called IP plus optical. IP plus optical solution is based on the Open Network Operating System ONOS. It was developed through the SDN open source platform. And with IP plus optical implemented on the SDN controller, now if a failure occurs for optical fiber transmission, the IP plus optical controller rehomes the failed wavelengths, lambda 2 in our example. The traffic 1 can still exclusively use the wavelengths lambda 1 of fiber 1. The SDN IP plus optical router will automatically use another wavelength for traffic 2. So this solution can provide more than 90% bandwidth usage in case of a failure. Let's come to the summary for the Huawei SDN IP core solutions. Huawei SDN IP core solution covers different methods for traffic optimization. First, RR Plus, which is used to steer inter-AS network IP traffic. The RR Plus module is located on the centralized SDN controller and is perfectly suitable to steer traffic from incoming and outgoing direction because it's providing a global network view. Then the Huawei SDN IP core solution also covers second advantage, path computation element plus, PCE plus with smart traffic engineering. This solution is based on PCE protocol and describes a powerful concept to realize traffic steering in an MPLS environment. And finally, the SDN IP core solution from Huawei also provides a mechanism to integrate IP routing and optical transmission on the SDN controller. This function is called IP plus optical. It is a cross-layer service function which dramatically can improve protection and resource planning issues for optical networks. This slide now gives an overview about the requirements for network devices if implementing Huawei's SDN IP core solution methods. If using RR+, no requirements are necessary for the network elements. If using PCE+, the network devices must support PCC, Path Computation Client. This can be co-located on the same network element or separate. For smart traffic engineering, the network devices must support OpenFlow protocol because the traffic forwarding in this scenario is based on OpenFlow flow tables. If using IP plus optical, we also need network devices which support PCC, Path Computation Client, generalized MPLS UNI and generalized MPLS UNI extensions. Generalized MPLS is a protocol suite extending MPLS to manage further classes of interfaces and switching technologies such as wavelength switching and fiber switching. So this is an essential part of IP plus optical. Let's shortly talk about operation and maintenance of network elements. The current mobile backhaul access solutions require manual configuration for each access device, cell-side gateways or aggregation devices. So this means a lot of configuration work to do, and this is not at all efficient. SDN-based mobile backhaul will use a control agent for each access device. This control agent is able to deploy configuration for each of the cell-side gateways in an automatic way. This will really simplify the operation and maintenance of the mobile backhaul network elements and of course will improve efficiency when deploying or changing networks a lot. It can also reduce the risk of misconfiguration. So finally, it will help to improve O&M and will help to save costs to the carrier. So this course gave an introduction to Huawei's SDN all-service solution with some focus on SDN architecture, on key features and on several types of the SDN all-service solution from Huawei. Thank you for watching.